Hey all, so this is the fourth video on factoring. Still starting with the GCF, and then for this section we're going to see some two-term problems, and these are going to be the ones with perfect squares on the ends, and likewise some three-term problems with perfect squares on the ends. So that's going to round out our three terms. Okay, so starting with our two-term problems, still always have to look for a GCF, and in this case we have a 2, so we'll take that out front. That's going to give us 25x squared minus 9y squared. And then you can see 25 and 9 are perfect squares, as are the x and y. So this is two terms with squares on the ends. I put the formula up here. When we see difference of squares is what this is called. We basically take a square root, or what times what makes 25, so that would be 5. And it goes just a plus b, a minus b, so kind of the roots of these. So 2 just comes down in front with GCF, and then it's going to be 5x plus 3y, and then same stuff, 5x minus 3y. Number 28, this one has a fourth power, so that means it might go a little bit further than just factoring once. I do have squares on the ends, so it's going to go 4x squared now, plus 1. And 4x squared minus 1. If you multiply back, 16x to the fourth, so that's what we're supposed to get. A sum of squares, so when we have a squared plus b squared, that is prime. So it's never going to factor, so that's this piece. So we just bring it down just like we did at GCF. This piece though, this is another difference of squares because we still have squares on the ends, so we can go one more step. 2x plus 1 and 2x minus 1. So the next are the last of the three-term problems. And so these ones go, when we have something of the form where we see these squares on the ends, the middle has to be something particular, but we'll use that as our check at the end. But the form of these is a squared plus 2ab plus b squared. And those are going to factor, this one factored to a plus b, a minus b. This one's going to factor to a plus b, a plus b. And a shorthand way of writing that is a plus b squared. But it's two positives. So this is our mixed signs, this one's our two positives. So when we see this, it breaks down very similar to this does. So 4x squared we break down to 2x, because 2x times 2x gets us back to the 4x squared. And then the 81 will break down to a 9, because 9 times 9 is 81. So the check I mentioned is the 2ab. Whenever I see the squares, I just kind of assume it's going to be one of these, and then I double check and make sure it was. So this is a, this is b, so if I go 2 times a times b, it should make 36x. So 2 times a is 2x, and b is 9. So that'd be 436x. So it is what we think. So I just kind of do that in my head. 18 times 2, different 2, but I just use that as my visual cue. And that gives me that middle term. So this one right now isn't squares on the ends, but we don't want to just run off and do magic method until we look for a GCF. And so here I can pull out, looks like a, can we pull out a 5? So I'll do a 5 out front, and then that's going to give me 4x squared plus 12x plus 9. Now I can see the squares on the ends, so bring down the 5. This will be 2x plus 3 and quantity squared. 2 times 3 is 6, doubled is 12, so that'd be our check. Okay, so 31 has a GCF of x squared. So pull that out and get 81x squared minus 180x plus 100. And then I see the squares on the ends. That makes me think it's going to do this. 9x. And then this time it's a minus in the middle, so that just makes it be a minus right here. So 9x minus 10 squared. And the formula for this one just goes a squared minus 2ab plus b squared is going to make a minus b, a minus b. So that's our double negative, or a minus b squared. This one, same basic thing, just an extra letter, so it breaks down exactly the same. So 7x r squared, so that's just going to be r, and quantity squared. Multiply them together, get 7xr times 2 is the 14. The next 6 or so, I think, are the ones that have you guys try, so I'll go through these a little quicker. Let's see, what can I pull a 3 out of this? So it's going to be 16x squared minus 9. And then that's going to be our difference of squares, so 4x plus 3 and 4x minus 3. 34, we got to 4th power, so probably going to go an extra round. This is going to go 9x squared plus y squared, 9x squared minus y squared. And so there's our prime piece, our sum of squares. So we'll just rewrite that. And then our difference of squares right here, still perfect squares, so we can go 3x plus y and 3x minus y. Okay, and then we get the 3-term problems, so we know they're going to kind of go like this. Since this is a minus, it's going to do that. So when you see the squares on the ends, you want to kind of think this form. And then 25x squared is 5x, 64 break down to 8. And just to make sure it's what we think, 5 times 8 would be 40, and doubled makes our 80. Over here, let's see, I think I can pull a 6 out. So that's going to leave me a 9x squared plus 6x plus that 1 placeholder. So 6 down front, squares on the ends, so 3x plus 1, quantity squared. And I double check, 3 times 1 doubled would make 6. Down here we have just an x squared running around, so we'll pull that out front. 36x squared minus 132x plus 121. And x squared, 36 is 6 squared, so 6x minus gets us minus. 121 is 11 squared, and so 6x minus 11 quantity squared. And if we go 6 times 11, that's 66, double it, and then that will be our 132. And last one for this section, we have 25, 144, so already perfect squares. So you just write down the answer. So 25 breaks down to 5, 144 is 12. 5 times 12 would be 60, XR, and then doubled, 120.